So we had just gotten to this idea of having independent and dependent variables. And so if you have any sort of independent variable, you should recall from calculus classes that you can have derivatives with respect to independent variables. So that would give us like du dx or du dt. Well, actually, let's go ahead and do it properly. So partial derivative of u with respect to x, or partial derivative of u with respect to t for u a function of x and t. Oops, sorry, I just hit the mic. And then you could take higher order derivatives as well. So, you know, d2u dx squared, or du d2u dx dt, mixed partial derivatives, maybe even like an nth order derivative is possible. And so this collection of possible derivatives of u with respect to its independent variables are what will make up differential equations. So vocabulary continues. More formally now we can say a differential equation is, well, for u is an equation that describes the relationship between u and its derivatives. And you could wonder a little bit later about why we would care about this type of equation, but for now, that's just how we're going to think about these things. And in this class, we will focus on ordinary differential equations, which concern derivatives with respect to only one variable. So just to kind of show you what I mean, that du dx equal to 3u is an ODE, ordinary differential equation. But if I had du dx plus du dt equal to 3u is not ODE. We would actually call that a partial differential equation because it has partial derivatives in it. We'll just do that. And then we're going to have to classify differential equations in special ways in order to recognize the way that we solve them. So we will classify ODEs according to important characteristics that tell us how to solve them. And so I think this is going to be our last little slide of vocab words for a bit. And it's going to be all about those important characteristics for any differential equation that we're working with. And so they're going to be order, linearity, and homogeneity. And we might switch that to homogeneous when we get to it. So order is going to be an idea that refers to the highest derivative in the equation. So du dx, first order, d2u dx squared, second order, and so on. We'll do more equations, more examples so you can become more familiar with that later. But for now, that's just going to be like a quick note to yourself. When I say highest derivative, I'm talking about the number of derivatives with respect to a particular variable. Linearity is going to sort of mean not multiplying a variable or its derivatives together. So the way that you're going to see this a lot is going to be sort of like having some a sub n of x. We should do that in the fraction notation that I've been doing, times the nth derivative plus some different function with respect to only x of the next derivative, all the way down to a1 of x du dx plus a0 of x times u. All of that can be equal to some function of x. And so this is okay because all of the derivatives are separate from each other, and the only thing they're multiplied by is functions of x. So they're not multiplying the variable of interest, u, with any of the derivatives. Again, we'll do some examples later that give you more solid understanding of this. That's just sort of the most general representation of what it means to be linear. And then homogeneity is kind of harder to describe. In words, it's sort of if the well, the way I wrote it is left-hand side because I ran out of room. But if the non-derivative side of the equation is 0, when you isolate the dependent variable and all its derivatives on the other side. And we'll see examples that make that a lot clearer, but sort of just using the same equation we had before, if you have 0 equal to all that other stuff, that's homogeneous or homogeneous, depending on how lazily I'm speaking. And 0 equal, f not equal to 0 equal to all that same stuff would be non-homogeneous. And if you like really care about spelling, I guess that wasn't very helpful to you. I think it's spelled like that, homogeneous and homogeneity. Yeah. Just being able to recognize that that 0 is important is really what's going to matter here. Being able to spell it or remember that word off the top of your head isn't going to be as important. So I'm going to go ahead and stop right here. We'll launch into some examples in the next video, so click on through whenever you're ready to